Okay, we're going to go over the answer key for yesterday's assignment and getting ready for tomorrow's quiz. Problem number 1. The number of years it took a random selection of former smokers to quit smoking is listed in column A. Using a 10% level of significance, is there enough evidence to reject the claim that it takes 10 years to quit smoking? That's for part A, 10 years. Okay, I have the answers here. We'll go over part of it, and I'll show you how to use some of the functions yet again. First thing we need to know is the sample mean, which is the arithmetic, or the average of the values in cells A1 through A32, as stated up here. And we also need to know the sample standard deviation, which is the stdev.s function for also for cells A1 through A32. Then over to the side, I've started to find the p-value, but because this is a two-tailed test, we have to find the area in one tail first and therefore double it. So just going over how I came up with this value of approximately 41%, I'll go over it again in the orange square up above that. We're going to use the function norm.dist, and the first argument in the function builder is, it says x, it's x bar, the sample mean, which is in cell C8. And the mean is the stated value for part A of 10 years. The sample standard deviation as far as the function builder is concerned is the standard error, which is the sample standard deviation divided by the square root of 32, because that's how many entries we have, value for n. And cumulative is true. We say okay, and we get the same answer once again, 0.413513128. Okay, but that's only the area in one tail, so in order to answer the question, find p-value, we have that value is doubled, and that's being completed in cell G8. And as you can see, it's just double the value in the cell F8. And because that's not even close to being less than 10%, as stated as the level of significance in the problem up above, we failed to reject the claim. There is not enough evidence to reject the claim that it takes 10 years to quit smoking. Okay. For part B, it's exactly the same thing for the sample mean and the sample standard deviation. And we'll go over the norm.dist function again being used. As you can see, it turns out to be approximately 6%. Choosing that same function, norm.dist, we have the value for x bar is in cell C12. The mean now is 11, as stated in part B of the problem. The sample standard deviation divided by the square root of 32, and cumulative is true, or 1. And we get an answer of approximately 6%. When doubled, gives us 12%. 12% is also not less than the 10% for the level of significance. So therefore, because it is greater than 10, we fail to reject the claim. And once again, there's not enough evidence to reject the claim that it takes 11 years to quit smoking. But on part C of the problem, again, we have the same sample mean and the same sample standard deviation. Once again, using norm.dist. The only difference now is that the value that goes in for the mean, okay, we still have the same x bar. We have the mean is now 12, as stated in the problem for part C. Standard deviation is sample standard deviation divided by the square root of 32, so standard error once again, and cumulative is true, Once again, I only state 1 for true. And we get approximately 0.2%, 0.002 for a proportion. And therefore doubled, that's still less than half of a percent, as you can see, 0.004. So that's far less than the 10% for the level of significance. So therefore we can reject the null hypothesis. There is enough evidence to reject the claim that it takes 12 years to quit smoking. On the next page, problem number 2. A manufacturer claims the life of an LED bulb is at least 10,000 hours. You want to test this claim. In column A are the results of your test. And once again, we've tested 32 light bulbs. Over to the side, I've listed the null hypothesis as being greater than or equal to 10,000. Therefore, the alternative hypothesis is less than 10,000. And this indicates that we're making a left-tailed test. Okay, so whichever direction the arrow is pointing on the alternative hypothesis, that is it's pointing to the left, so it's a left-tailed test. So just like on the first page, we find the sample mean from the data entries in column A. The sample standard deviation is stated in cell D6, and the p-value, I'll show you once again how I compiled that. It's the norm dot dysfunction. Well, I'll just show you the final result right there. And just redoing that, norm dot dysfunction is selected. The value for x or x bar is the 9580 value in cell C6. The mean is stated as being 10,000. The sample standard deviation is what we look for next, divided by the square root of the sample size, n is again 32. So that's the standard error, and 1 for cumulative. And we have the answer, as you can see, approximately 8%, almost 8.5%. But in any case, it's 8%. It is not less than the 5% as stated in the problem up above. So therefore, we failed to reject the claim. Okay, the p-value is greater than the level of significance. So we failed to reject. But on part B, it says if we gather more evidence, 100 bulbs with the same sample mean and the same sample standard deviation, would you then have enough evidence to reject the manufacturer's claim? So everything from part A is exactly the same. So the sample mean, I just copied down. Sample standard deviation, I just copied from above. And the p-value is using the norm dot dysfunction. The only thing that's now changing is the sample size, the value for n, the 100 as stated up here. So I'll go over that as well. And selecting the norm dot dysfunction, the value for x is cell C12. The mean is 10,000. What goes in for the standard deviation is the sample standard deviation divided by the square root of 32. And cumulative, once again, is true. 1 for true. As you can see, it says true right there. And you simply say OK. And oh, I put in the wrong sample size, so we'll change that. That's the difference between this problem and the previous one. Sample size is now 100, and we get less than 1%, which is far less than the 5% for the level of significance. When the p-value is less than the level of significance, the maximum error allowed, we have reject the null hypothesis. Okay, so therefore we're rejecting the claim that the light bulb lasts at least 10,000 hours. Okay, hopefully all that helped, and we'll see how the video came out. Good luck on tomorrow's quiz.